Okay, the second packet's really easy. You really don't even need a calculator for it, I don't think. Okay. This is a load of crap. This is a load of crap. And let's take a look at this. Actually, no. Let's look at this page right here. Writing numbers in scientific notation. Give you a chance to find it. Okay, here's a point. Scientific notation is taking a number with many digits and just shortening the number. That's the only purpose of scientific notation. Okay. Now, this is how I teach it. My way of teaching is a little unorthodox. It's always worked well for me. I don't know, maybe this will be different. Could be. Look at that number. Is that less than one whole or more than one whole? Well, 0 point with anything is less than one whole. So if it's less than one whole, can you please put a negative sign and circle it? Now, here's the next thing I do. Looking in this direction, I find the first number that's not a 0. 0, 0, 0, 0, 0, 0, 5. Put a decimal after your 5. Now, here's that decimal you just wrote. We write 5.4 times, and we use a 10 as our base. And all I do really is count the digits between the first decimal and the one I put there. So 1, 2, 3, 4, 5, 6. 6 is the power, but it needs to be a negative. And there we have it. 5.4 times 10 to the negative 6 power. By the way, the reason you always use base 10 is because when you, like, 100 is 10 times 10. 1,000 is 10 times 10 times 10. 10,000. 10 times 10 times 10 times 10. 100,000. 5 tens multiplied together. 1,000,000. That has 6 tens. All those, like 1,000,000, 1,000, 100, 10,000, those are all what we call powers of 10. And really what they do is add zeros, move the decimal, so forth. That's why it makes it kind of easy. Okay, now I'd like you to look at this one. 6,700,000. Is that bigger than one whole? Yeah. So it's going to be a positive power of 10. Okay, so look in this direction. First number that's not a 0, bam, right there, 6. Put a decimal. Oh yeah, by the way, your starting decimal was at the end. If you don't see a decimal there, put one at the end. Then you put your own after the first non-zero number. Okay, so here's my decimal, 6.7 times 10. Now count the digits, 1, 2, 3, 4, 5, 6, 7, 8, 9. The power is 9, and it needs to be a positive 9th power. Okay, next one. Here's my decimal. By the way, number I started with is less than one whole, so we're going to have a negative power of 10. 0, 0, 0, 0, 0, 0, 0, 0, 4. Okay, so I assume I have 4.06 times 10. Count the digits between them. 1, 2, 3, 4, 5, 6, 7, 8. So 8. Make him a negative power. Okay, next one. Here's my first decimal. Obviously less than one whole, so less, so negative power. So 0, 0, 0, 0, 0, 0, 0, 0, 7. Okay. So 7.008 times 10. Now count the digits between them. 1, 2, 3, 4, 5, 6, 7, 8. Negative. Okay, next one. Obviously bigger than one whole, so that's a positive. Now the decimal that they give you is actually at the end. It's like an invisible decimal. Now you got to put your own. Bam, right there. Not a 0. It's going right there. So 4.709, don't write the zeros after, times 10. 1, 2, 3, 4, 5, 6. So 6, positive 6. positive. Okay, their decimals at the end. Bam, 1. So 1. So 1.544 times 10. Count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 1.544 times 10 to the power of 10. Okay, that's obviously going to be a negative because it's less than 1 whole, so we need a negative power of 10. Looking this way, there's a first decimal. So 0, 0, 0, 0, 0, 0, 0, 7. So 7, okay? So really it's just 7 because there's nothing after times 10. Now count your digits. 1, 2, 3, 4, 5, 6, 7. Negative is what we have. Okay, next one. Obviously bigger than 1. Decimal here. And then looking this way. Bam, 8. It ain't 0, so it's going there. So 8 point, and then there's a bunch of zeros, so it's just 8 times 10. And 1, 2, 3, 4, 5, 6, 7, 8, 9 to the positive, to the 9th power. Don't worry about this crap. Okay, now find this page. It's actually on the back of the one we were just doing. Now, what they give you the number in scientific notation. You need to find the standard form number. That means you got to find what number that actually represents. So 2.75 times 10 to the 6, 2.75. Now your power of 10 is positive, so we make the number bigger going this way by moving the decimal. So 1, 2, now I'm out of room, so I start putting zeros. 3, 4, 5, 6. So 275,000,000. Put the commas, 2,750,000. Okay, this time 1.69. Now we have a negative power of 10, so I need to make the number smaller by moving it this way. So 1, 2, 3, 4. Now I have a decimal at the beginning. When I have a decimal at the beginning, I need to see that in my answer because it's 0.000169. It's less than 1 whole. 7.8, back to a positive power of 10, so we make the number bigger. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, decimals at the end, so I don't need to put it in my answers. So 78,000,000. 78 million. Okay, 3.2. Now we're back to a negative power of 10, so we're going this way. So 1, 2, 3, 4, 5. Put your 0 in front, so 0.000032. Okay, scientific notation. Now the only thing, you have to do the assignment, but it's pretty easy. 1 through 8. Okay, you do the 1, 2, 3, 4 on that page. You're writing it in scientific form, so times 10 to the power of something. And then here you're going the other way and writing it in standard form. The rest of this packet's a lot of crap and garbage that you don't need.